Okay, so I got you guys started on the tables. And this is just to help you see the formula. If you see why it is what it is, then hopefully it'll help you remember it. Okay, so if I want to find the eighth, how many she dropped on the eighth tile, what would I do?
2 times 3 is 7.
Yes. And that's a lot of crumbs.
She just stopped eating at that point. She ain't eating that.
She doesn't have any food left at that point.
She look like me.
All right, and then so the nth tile is still 2 times 3, but what would the power be?
N minus 1.
Yes. That's the formula, basically. It's the first term or the first amount, and then what you're multiplying by each time raised to the n minus 1. Okay, so then to get the third, how many total crumbs she's dropped when she gets to the third tile, you add the first, second, and third tile crumbs and get 26. And the fifth, you add the first, second, and third, which is, we already know, 26, plus the fourth and the fifth, 242. You can go. All right. And so you guys do not have to write number 6. Just watch me. Don't just look at your phone and not pay attention. Watch me do it. And you might help me out just a little bit. All right. And so we're going to create a shortcut to find the sum of a whole bunch without having to add them together. So I'm going to use the fifth as an example. So the sum of the first 5 terms would be the first, which is 2. And you do not have to write this if you don't want to. And then the second was 2 times 3, 2 times 3 squared, 2 times 3 cubed, 2 times 3 to the 4th. Right? And now I'm going to do something, and I'm going to take that list, and I'm going to multiply it by another 3. You do not have to write this if you don't want to. So when I take this 2, and I multiply it by another 3, it's just going to be 2 times 3. All right? And then when I take this one, and I multiply it by another 3, it's going to be 2 times 3 to the what power? If I multiply it by another 3.
1.
It already is a 1.
Oh, so
2, yes. All right, then I'm going to take this one and multiply it by another 3. The next one multiply by another 3. And the last one multiply by another 3. All right, now I know all that seems weird. So now I'm going to take these lists and I'm going to subtract them. And it's not going to be as hard as you would think. So this 2 is still going to be in our subtraction. But what happens to these when I subtract them? Yeah, this cancels, this cancels, this cancels, this cancels, and we're left with this last one. So 2 minus 2 times 3 to the 5th. All right. Now, I'm going to factor a common factor out of each side. So on the left side, bless you, what they have in common is s sub 5. I'm going to factor that out. When I do factor that out, what am I going to be left with? If I factor it out of itself, what are you left with? I do have a negative 3 over here, but what about when I factor it out of itself? It's a 1. Good. All right, what's the common factor on the other side? What do they both have? A 2. So I factor it out of itself. All right, now my whole goal is to solve this for s sub 5. So what would I do with this stuff if I just want the s sub 5? Divide. All right, that's it. So s sub 5 is going to be equal to this big fraction where I have 2 times 1 minus 3 to the 5th over 1 minus 3. And let's talk about the parts of this so we can do the 16th tile without having to find all the 16 and add them together. So what was this 2? What was that 2?
Oh, is that it?
The first term, right? What about this 3?
Is it D?
It's not D on this. It's something else. It's a different letter for multiplying. It's not a difference. It's a ratio, so it's R. And then 5 was the N. 5 was how many we were adding up. So we're going to do this for the 16th. And you can write this down. Write down number 7. Right, 2 is still going to be the first term. 3 is still going to be your common ratio. But what power do I need to use this time? The 16. All right, and then you can straight type that in your calculator. It might give you scientific notation, I don't know, but it's going to be 43,046,720 crumbs, which is probably not possible unless she was eating like 5 cakes or something. I don't know.
The fact that she just walked around making a mess is crazy.
Okay, so on the other side, we're going to write all the formulas that we're going to need, and we're going to do some examples. So I just wanted to show you where that formula came from. So hopefully when you have to use it, you'll remember it. So I know a lot of times you just accept a formula is true without really seeing it happen. But geometric sequences have a common ratio. And we're going to call that common ratio R. And if you want to find R, you just divide a term by the previous term. So you could do the second divided by the first, or you could do the fifth divided by the fourth. As long as they're consecutive, you just divide them and it gives you the common ratio. All right. We already figured out how to do the explicit formula because you did it on the other side of the paper. So on numbers 1 through 4, you were figuring out the explicit formula. So if I want to find the nth term, a sub n, I just take the first term and I multiply it by the common ratio raised to the n minus 1. Can you do this if it's not the first term that you know? You still could. So you could also do any term, so like a sub c. And then instead of raising it to the n minus 1, what would you raise it to? The n minus c. So whichever term that is, just subtract that from n. You don't see that formula a ton, but I like that formula. It comes in really handy. So you can do that with any term. All right, and then the sum formula. This is also called the nth partial sum. Sometimes you see that instead. All right, so that's the one we just came up with on the other side where it's S sub n. So anytime you see the S, it means the sum. It's going to be a fraction. In the numerator, it's going to be a sub 1 times 1 minus r to the n. In the denominator, it's just going to be 1 minus r. All right, so you have about 4 formulas that you're going to need to have memorized before our test, which I think is going to be it's either next Wednesday or Thursday. Oh, we're going to learn one more tomorrow, too.
So 4 more tomorrow?
One more tomorrow.
We just had a test.
I know. This is a short.
This is the whole
Mm-hmm.
unit.
This unit is really short. But this next test will go on the last quarter because the grades end on Friday. All right, so let's look at number 1. So we're going to write a formula for this sequence. is this a geometric sequence? Are we multiplying by something each time?
Times 5.
Yeah, so r is 5. So all we have to do is say a sub n equals the first term times 5 raised to the n minus 1. And that's it. So easy if you can remember the formula. This next one is not as straightforward. And we did these with arithmetic sequences where we knew the fourth and we knew the seventh and we wanted to find the first. So I'm going to do this kind of the same way. So this is the first, second, third. I know the fourth term is 48. Fifth, sixth. I know the seventh is 384. So we have to first find the common ratio and then find the first term. All right, so if I go from the fourth to the seventh, I'm going to multiply by an r, and then another r, and then one more. So 48 times r times r times r is going to be 384. What is r times r times r? You guys are so smart. All right, then we're just going to solve this for r by dividing by 48. And then this is what r cubed is. What do we do to find what r is? Take the cube root. Do you guys know what the cube root 8 is? Yes, 2. So we're multiplying by 2 each time. So this would be 96, and this would be 192. I'm having a hard time with my numbers today. And then multiply by 2 again, and it'd be 384. But that's not what we needed. That's just extra stuff for you. I want to go the other way. So if I'm going the other way, what do I do with the 2? Divide by it. Good job. So that's going to be 24, 12. So the first term is 6. All right, so that is somewhat tedious. You can't just straight use a formula. You have to do also some thinking. But number 3 is pretty much just straight using a formula. So we are going to use the formula for the nth partial sum. So I called it that. So I usually just call it the sum formula. For the sequence given by 3, 9, 27, 81, 343 up to the 15th term. So we're finding the sum of the first 15 terms. Okay, so I'm going to use that green formula. So the first term here is 3. What are you multiplying by each time? Also 3, good. And that's going to be to the 15th. That was weird. Over 1 minus 3. And again, I think that you can just straight put that in your calculator and it will give you the answer. It might give you scientific notation. I don't know. But this is 21,523,359. So these sums, like when you're multiplying by 3 each time, they add up really, really fast. All right, and then this last one is the application problem. So the first week of July was the opening week of the Deluxe Hotel. It had 200 guests that week. In the weeks immediately following, the bookings decreased by 5% each week. All right, so if they're decreased by 5% each week, how much is remaining each week? 95. So R here is 0.95. So 95% as a decimal. Now, if they had increased by 5%, then what would R be? 1.05. 1.05. Good. So you either subtract that percent from 1 or add it, depending on if it's increasing or decreasing. Okay, so A, we want to know how many guests did the hotel have in the 11th week. So it's asking basically for the 11th term. So we're going to use the red formula where there's 200 the first week. We're going to multiply by R. And then what do I raise it to? To the 10th. So we subtract 1. 11 minus 1, or the 10th. All right, so since it's decreasing, this should be less than 200, and it is. But we don't ever want to give the answer as a partial guess. That's kind of gross. So it's going to be 120 guests. And then B wants us to know how many total guests did the hotel have during the 13 weeks of July, August, and September. Which formula are we going to use this time? The red or the green? Green. We're going to do the sum. So S sub 11 is going to be this fraction formula where we do the first term or the first week, 1 minus R raised to the 11th over 1 minus R. Right, and then you can just type that in the calculator. And again, we don't want to give a partial guess.
I do apologize. So
Okay, and then this last one, we want to know which week did the hotel have their 3,000th guest? What do you think? Are we going to use the red or the green formula? Green. So we're adding up all the guests that they have ever had, the 3,000th guest. So it's going to look similar to this one, except we're going to put in 3,000 for the S sub whatever. And we have to figure out what this power is. So that's going to be the N. Then I'm going to go ahead and subtract 1 minus 0.95 because I already know what that is. In the denominator. We cannot do that in the numerator because the 0.95 has an N. All right, so we need to solve this for N. This is going to be quite a few steps. And we could do things in different order. I'm going to go ahead and multiply these two together. So 3,000 times 0.05 is going to be 150. All right, then what would you guys do? Our goal is to get this part right here, this exponential part, by itself. So what? Good. Sorry, you guys don't have a lot of room to get all this done. So this is going to be 0.75 equals 1 minus 0.95 to the N. All right, what would you guys do with that 1? Yes, subtract it. Oh, change variables. All right, so anytime you have a negative equals a negative, you can just drop off the negatives. It's like dividing by -1. That's fine. As long as that negative wasn't in the parentheses with the power on the outside, you can do that. Okay, there's only one thing we can do to get this exponent down. What is it? You just took a test over it? Logs, yes. So it's going to be log, and then we use the base, which in this case is 0.95 of 0.25 is going to be equal to N. And then you just do the log base in the calculator. I can look at a calculator and tell you, but I can't remember straight off the top of my head sometimes.
2572.
It's not what I got.
27
It's 27.
Why is that funny?
26.
Looking at you, like,
Okay, we should get 68.
So it's after the 27th week is when the 3,000th guest is going to arrive at the hotel. So it's the 28th week. It's a little bit tricky there at the end. All right. So what questions do you guys have